Namaste. In this video, let us explore the basics of Geographic Information System or simply GIS. It is a powerful tool that helps us to understand the world through maps and data. Step by step, we will see how GIS connect places, people and information. A Geographic Information System is a computer-based system used to represent, analyze and manage geographic features on the Earth's surface. It combines information about locations such as position of specific features with their attributes such as their type, size, shape, name, etc. This makes GIS a powerful tool for understanding spatial relationships and solving real-world problems. GIS works by graphically displaying geospatial data in the form of maps. For instance, it can create maps of roads, rivers, or land use tailored to users' needs. Beyond just showing locations, GIS allows for analyzing data to answer complex questions. For example, it can determine shortest path from fire station to the nearby library, or how land use can change over time, and so on. One of the key strengths of GIS is its ability to manage and update data efficiently and intelligently. It ensures that geospatial data remains accurate and relevant. GIS is more than just a mapping tool. It is a versatile system for visualizing, analyzing, and interpreting geographic and attribute information, enabling better decision making in countless areas. A geographic information system is a powerful tool that helps us to represent and analyze information about the world in a way that is easy to understand and use. Imagine visiting a museum where you want to plan your visit efficiently. At the entrance, you will see a computer screen displaying a map of the museum. As you move the mouse over the map, it highlights areas of interest and even shows the best route to get there. This is GIS in action. It retrieves information quickly and presents it in a user-friendly way. Before GIS, traditional maps were used to find locations which required more time and effort. For example, locating yourself on a map and planning your route involved manual searching and interpretation. With GIS, this process is simplified and faster. You can instantly find your current location and the best route to your destination. GIS is essentially a way of representing the world on a computer, similar how maps represent it on paper. For example, if you want to locate all petrol pumps in a specific area, GIS software can quickly display their locations, helping decision making much easier and more efficient. Traditional paper maps have several limitations. They are created at a specific scales and projections, making it difficult to combine maps of different types, scales, or areas into a single integrated map. For example, if you wanted to overlay a road map on a land use map, the process would require significant effort to match their scales and coverage areas manually. This is where Geographic Information Systems comes in as a transformative tool for managing and analyzing spatial data. GIS provides flexible and dynamic way to handle maps and spatial information. It allows maps of different scales and projections to be adjusted and converted into a uniform format, enabling seamless integration. Unlike static paper maps, GIS offers the ability to extract detailed information about any feature at a click of a button. It provides users with tools to create interactive queries, analyze spatial relationships, and even edit and update maps as they need it. Another critical advantage of GIS is its ability to present the results of complex analysis in a visually appealing and easy to understand manner. Whether it's planning the shortest route between 2 points, or analyzing land use patterns, or monitoring environmental changes, GIS offers comprehensive platform for data visualization and planning. In a sense, GIS goes far beyond the capabilities of traditional mapping. It is also a modern tool that is not only simplifies map creation and data integration, but also enables advanced spatial analysis, making it indispensable for a wide range of fields like urban planning, environmental conservation, disaster management, transportation, and so on. A geographic information system or GIS is made of several key parts that work together to handle and understand location-based information. The first part is hardware, which means the computer or servers where GIS runs, from personal desktop to powerful systems used by many people at once. The second part is software, the set of tools used to create maps, store data, and analyze patterns. Popular examples you may hear about QGIS or ArcGIS software tools. The third part is data, which is the heart of GIS. This includes spatial data showing where things are, like rivers, roads, and non-spatial data describing what they are, like their name, size, type, and so on. The fourth part is people, because technology alone has no purpose unless skilled users apply it. This may be city planners, scientists, or everyday professionals using GIS to solve real world problems. Finally, there are methods, which are rules and practices that guide how GIS is used in different situations. Together, these components make GIS a complete system that helps us to collect, analyze, and share information about the world in a smarter way. GIS data acquisition simply means how we bring information into GIS. Data can come from many sources like satellites, images, GPS, devices, surveys, or even existing paper maps that are scanned and digitized. Sometimes new data is collected directly in the field, while other times it is downloaded from different databases and so on. Once gathered, this information is organized and converted into a format that GIS can use. In short, data acquisition is a first step that makes all GIS analysis and mapping possible. Data is the backbone of any geographic information system because every analysis and map starts with it. GIS uses many types of data that come from different sources and exist in different forms. One major source is remote sensing, where satellites or aircrafts capture detailed images of Earth's surface. Another source is GPS, which gives us very accurate location points that are useful for mapping and navigation in real time. Traditional paper maps can also be digitized and used in GIS, allowing us to compare present-day conditions with historical maps. Government and research agencies often provide ready-to-use digital data in formats like vector and raster data. Census data, surveys, and other statistics are also powerful sources when linked to a specific places. Digital elevation models gives us the shape of the land, which is useful for terrain studies or 3D views. Even photographs and text information such as names or descriptions can add value when we connect it with the location. Together, all these sources make GIS versatile and powerful for understanding and solving real-world problems. Remote sensing data plays a pivotal role in GIS, providing a bird's eye view of the Earth's surface. Capturing through satellites and aerial platforms, this data encompasses a wide range of imagery such as optical, radar, infrared, and hyperspectral data. These images reveal critical details about land use, vegetation, water bodies, or urban infrastructure, or any land use. For example, in Karnataka, land use maps were created for 2020 and 2021 using satellite data. The satellites capture detailed images, and then computer techniques like machine learning were used to classify areas into cropland, forest, shrubland, grassland, built-up regions, and water. Each land type was given a different color, such as green for forest or pink for cropland, to make map easy to understand. Once processed, this information is brought to GIS, where users can analyze changes, measure areas, or manage resources. In short, remote sensing works hand in hand with GIS to create powerful maps that support real-world decisions. GPS, or Global Positioning System, gives us accurate location data by using signals from satellites orbiting the Earth. This data is collected in real time and is very important for mapping and navigation. In GIS, GPS helps to mark exact points like roads, buildings, or rivers, or landmarks, making spatial data precise. It is widely used in transport, navigation, and in the field surveys to find positions quickly and accurately. When GPS is combined with Geographic Information System, we can track movements, monitor resources, and even update map instantly as things change. This creates dynamic maps that are always updated and reliable. In short, GPS provides location and GIS turns the location into meaningful maps and analysis that can guide better decisions. Paper maps, though old-fashioned, are still very valuable sources of GIS data. They often show land use, boundaries, or natural features from the past, giving us a record of change over time. With GIS, these maps can be scanned, georeferenced, and turned into digital data. This allows us to preserve them and compare past and present conditions and enrich our analysis. For example, the map here was created in the 19th century by William Wilson Hunter and is preserved in the British Library. Such historical maps become powerful resources once digitized in GIS. Scan drawing like architectural plans or engineering layouts are also important sources of GIS data. They show detailed information about buildings, roads, or pipelines or other physical infrastructures. When these drawings are scanned and georeferenced, they can be converted into useful digital maps or models. Scan drawings provide precise details that can be integrated into GIS. In this way, they connect design work with real-world spatial analysis. Existing digital data is one of the most important sources of GIS projects in practice. It includes two main forms: vector data, which uses points, lines, and polygons to represent features like roads or buildings, and raster data, which looks like images or grids. Many government agencies, research groups, and private organizations provide this kind of data. Examples include land cover maps, topo sheets, city maps, master plans, and so on. Because it is already digital, this data fits directly into GIS software, letting user to focus on spatial analysis rather than time-consuming data conversion. Statistical data such as population figures or economic indicator enhances GIS by adding a quantitative dimension to the spatial analysis. This data is often linked to geographic locations, enabling users to analyze patterns, trends, or relationships. For instance, census data can be used to study population distribution, while health statistics can reveal areas with higher disease prevalence. GIS integrates statistical data with spatial datasets, creating powerful visualizations like heat maps or thematic maps. By combining spatial and non-spatial data, GIS users can derive actionable insights for policymaking, resource allocation, and community planning. Digital elevation models or DEMs are essential for understanding the topography of Earth's surface. This model provides a three-dimensional representation of terrain showing elevations and slopes. DEMs are widely used in GIS for applications like flood modeling, landform analysis, and infrastructure development. They help in identifying elevation patterns, studying watershed areas, and planning construction projects and so on. DEMs also enhance visualization by enabling 3D mapping, which offers more realistic representation of geographic features. Their versatility makes them a key component of GIS data sources, supporting both analysis and visualization. The visualization here represents a digital elevation model or DEM of India, illustrating topographic elevations of the region. DMs are raster datasets where each pixel contains elevation values related to sea level. In this map, lighter shades indicates higher elevations such as the Himalayas, which reach maximum elevation of about 8,564 meters. Darker shades represent lower elevations including plains and coastal areas. Aerial photos taken from airplanes or drones gives us a clear and detailed images of the Earth's surface. They show features like building, roads or forests and formulates from the above. When those photographs are georeferenced, that can be used in GIS to create accurate maps. Aerial photos are especially helpful in tracking small changes over time such as city growth or new construction activity and so on. By viewing land from above, GIS users can study patterns and relationships more closely, making aerial imagery a powerful tool for mapping and analysis. In GIS, data is usually divided into two types, spatial and non-spatial. Spatial data tells us where something is on Earth, like the path of river or boundary of a city or height of a mountain and so on. Non-spatial data gives us details about these places such as river's name or city's population or the type of soil in the region. Within spatial data, there are two main formats, raster and vector. Raster data is like a picture made up of small squares or pixels, with each pixel holding a value such as temperature, rainfall, or land cover, or simply surface reflectance. This format is commonly used for satellite images or aerial photos. Vector data, on the other hand, uses points, lines, and polygons. A point can represent a school, or a line can represent a road, and a polygon may be an outline of a lake or a forest. Both raster and vector data are important, and they are often combined in GIS to create full view of the landscape. So when you look at a GIS map with layers showing roads, rivers, elevation, and even population, remember these comes from different data sources working together to help us to understand our world better. Spatial data, also called geographic data, is the information that tells us where things are located on Earth. It shows the precise position, size, and shape of objects and helps us to understand how they are arranged in space. This data is usually stored as coordinates, which marks exact points on the surface. Spatial data can come from many sources like paper maps, printed photos, digital maps, or satellite images. In GIS, it is used to display, analyze, and visualize real-world features for many purposes such as city planning, environmental studies, transportation, or disaster management. There are two main formats of spatial data, raster and vector. Raster data is like grid of pixels where each pixel holds information about a location useful for images or continuous data. Vector data uses points, lines, and polygons to represent features more precisely, like a school, a road, or a forest. When they are used together, raster and vector gives us a complete way of mapping and analyzing spatial information. This makes spatial data the foundation of most GIS applications. Raster data is a way of representing information in GIS using grids of rows and columns. Each tiny box in this grid is called a pixel, and it represents a small area on the ground with a value linked to it. The size of a pixel is called resolution. For example, if the resolution is 10 meters, Each pixel shows a 10 by 10 meter area. Smaller pixels means higher resolution and with more detail in the imagery. Raster data is very common in GIS and is used for things like satellite images, scanned maps, or digital elevation models. It works especially well for continuous data such as representing temperature, rainfall, or land height because the values change smoothly across space. Raster data also can be combined with vector data in GIS, allowing detailed analysis by layering different types of information together. In some cases, raster can be converted into vector or the other way around. Because of its simplicity and flexibility, raster data is crucial part of geospatial analysis and remote sensing. Vector data is another important way of storing information in GIS and it is very precise. Unlike raster data, which is made up of pixels, vector data uses simple geometric shapes like points, lines, and polygons. Each of these shapes represents real-world features in detail. A point can show a well or a tree or a peak of a mountain or a city and so on. A line can represent road or river or railway or any linear feature. A polygon can outline larger areas such as park or a complete city boundary or a boundary of a lake and so on. Vector data representation is highly accurate because it captures the true size and shape of objects. For example, a river traced as a line follows its natural course, while a city boundary drawn as a polygon shows the exact extent. Vector data is especially useful for features that are separate and clearly defined, such as roads or property boundaries, etc. It also allows us to attach extra details like road names or population numbers to each feature. With vector data, GIS users can measure distances, calculate areas, and study how features connect. This makes vector data essential for mapping, analysis, and decision making in many fields. Non-spatial data, also called as attribute data, is a descriptive information about features without showing their location. While spatial data tells us where things are and its shape and size, non-spatial data explain its properties or characteristics. These attributes can be qualitative, like names or categories, or quantitative, like measurements or numbers. For example, a road map's spatial data will show the position and length of road, but non-spatial data will tell us if it is highway or street, or its width, its material, or its condition, and so on. This type of data is usually stored in tables where rows represent individual features and column represents their attributes. For a road network, the table might contain information such as road type, speed limit, or name, or maintenance status. In GIS, spatial and non-spatial data are linked together through unique identifiers, making it possible to query, analyze, and visualize both at once. Non-spatial data adds meaning and depth to GIS maps, supporting better decision making in areas like city planning, transportation systems, or environmental management. Together with spatial data, it provides complete picture of the features that we study. Geographic Information System or GIS is used in many fields like policy, planning, engineering, and more. In policy making, GIS helps leaders to see patterns such as poverty levels, healthcare needs, or effects of environmental rules so they can take better decisions and use resources wisely. In urban and rural planning, GIS maps show how land is being used and help to design sustainable cities, transportation routes, and infrastructure. It is also vital in disaster management to identify risk zones, plan evacuations, or guide emergency services. In engineering, GIS supports the design and monitoring of roads, bridges, water systems, and power grids by analyzing terrain and environmental factors. Even in agriculture, GIS helps in irrigation and crop planning, while in healthcare, it tracks disease spread and plans services. In environmental management, GIS keeps watch on forest, water, and wildfire. In short, GIS is a versatile tool that helps to make better decisions possible across many sectors. GIS plays an important role in town planning because it brings together spatial and non-spatial data in one place. Governments and city bodies use GIS to manage infrastructure, optimize land use, and even improve property taxation. By combining multiple datasets, GIS creates a digital model of towns showing property boundaries, land use, facilities, and services. For example, municipal authorities use GIS to digitize property records, send tax notices, and track collections more efficiently. It also helps to prepare local area plans by analyzing population, land usage, and available resources. With this, planners can identify places lacking in services like water, sanitation, or healthcare. GIS also supports tracking of infrastructure projects, monitoring health indicators, and evaluating progress in real time. By offering a single interactive platform, GIS makes planning more transparent and effective, helping towns to grow in a sustainable and organized way. This truly empowers urban governance. GIS is very important for public safety and defense. In disaster management, it cannot stop events like cyclones, floods, or earthquakes, but it can predict their impacts and guide quick action. For example, when a cyclone is forecasted, it can show which coastal areas may hit bad, allowing timely evacuation and proper resource allocation. In defense, geospatial technology supports planning by locating enemy positions, addressing vulnerable zones, and strengthening strategies with accurate data. It also helps in monitoring sensitive borders and improves real time awareness for security forces. In public safety, it guides rescue teams by mapping affected regions and showing the most critical location during emergencies. By combining accurate maps with the faster decision making, this technology ensures better responses to disasters and enhances national security and protects communities. GIS is now essential for managing utility services like electricity, water, gas, transport, and telecommunication. Utility providers use GIS to map their networks, showing their exact location and condition of infrastructure. In electricity, GIS helps to monitor power lines and substations, plan new connections, and find shortest routes for delivery. For water and gas, it pinpoints pipelines, highlight areas needing repair, and ensures smooth supply to customers. GIS also identifies regions where services may be disrupted, helping quick response during emergencies. By analyzing population growth and demand, it supports future planning of networks and infrastructure. It even helps with billing and collection by linking customer locations with service usage data. Overall, GIS makes utility services more reliable, efficient, and well managed, ensuring people receive resources with fewer interruptions and better planning for the future. GIS plays key role in infrastructure planning because it shows how people, land, and resources connect on a map. Planners can use GIS to decide where houses, schools, hospital, and roads should be built by looking at land use, population, and environmental factors. It helps to find safe areas away from floods or plan the shortest routes for emergency services. By combining maps with data, it reduces cost, avoids mistakes, and creates infrastructure that improves people's lives. That is the end of this video. Namaste.